Hey guys, today we're talking and we're starting a section on sequences and series and probability. This is going to be fun, it's going to be different, but it's some stuff that you'll definitely see again in college or even next year if you take statistics. So talking about sequences first. So sequences are like a long list of numbers that never end, but an infinite sequence is a function whose domain, or x values, is the set of positive integers. Remember, an integer are pretty much whole numbers when you're only talking about positives. Okay? And a function values a1, a2, a3, a4, a to the n. So these are just, when you have this a with this thing, these are just terms, okay? So these are just terms. We'll talk more about that in just a second. But those are the terms of an infinite sequence. Okay, we'll talk more about that and how to identify which is what term. A finite sequence is a sequence whose domain, consists of the first n positive integers, where n is just some specific number where it ends. Okay, so if n is 100, it's the first 100, whereas a sequence is forever, okay? It goes to infinity. All right, to find the first three terms of a sequence given an expression for its nth term, we're going to evaluate the expression for the nth term, so whatever that last term is, whatever, if it's the 100th term, you plug in 100, at n equals 1 to find the first term. So when n is 1, that just talks about the first term. To find the second term, you plug in n equals 2, and so on. To define a sequence recursively, you need to be given at least one or two of the first few terms. This is when we are given a few terms and we kind of have to figure out what the rest of the pattern is. All the other terms of the sequence are then defined using previous terms. And that's where this word recursive comes from. That this idea of recursive ties into this word of previous values, okay? So, for example, to find the first 5 terms of the sequence, here's what we know. To find the first 5 terms, the first term, we call that A1. The second term, we call that A2. The third term, we call that A3. The fourth term, we call that A4. And the fifth term, we call that A5. So here's what we're going to do. To find them, we're going to use our formula, but instead of n, we're going to plug in n is 1 for our first term. So we say 5 plus 2 times n, which is 1, times negative 1 to the 1 power. So that's really 5 plus 2 times negative 1 is negative 2, which is 3. So in this first one, it's going to be 3 for our first term. For our second term, we're going to say 5 plus 2 times 2 times negative 1 to the 2 power. Well, we know that's going to be 5 plus, this is 4, and then negative 1 squared is just 1. That's just 5 plus 4 is 9. So that's our second term. To find the third term, we're going to plug it into 5 plus 2 times 3 for n times negative 1 to the third power. That's going to be 6 times negative 1, because negative 1 to the third power is just negative 1. and that's 5 minus 6, which is -1. Okay. The fourth term is going to be 5 plus 2 times 4 times -1 to the fourth power. That's going to be 5 plus 8 times 1, which is just 5 plus 8, which is 13, is the fourth term. And the last term, a sub 5, or a5, we say is 5 plus 2 times 5 times -1 to the fifth power. That's 5 plus 10. -1 to the fifth power is just -1. So we end up with 5 minus 10 is -5. And then it can keep going on from there, but since we're just looking for the first 5 terms, these are them. Let's talk about factorial notation now. It's really fun. Factorial notation just looks like this. So n factorial is an exclamation mark, but in math we say this is a factorial. And factorial just means it's all the numbers up to whatever number n is, all multiplied by each other. So it'd be 1 times 2 times 3 times 4 times 5 times all the way up to the number before n times the last value of n. So if n was 20, it'd be 1, 2, 3, 4, 5 times 6 times 7 times 8 times 8, all the way up to 19 times 20. A 0 factorial looks like this, and the definition of 0 factorial is 1, just like any value to the 0 power is also 1. So if we were going to evaluate this factorial expression, we don't know what n is, but what's cool about this, I know n factorial, and then n plus 1 factorial tells me that it's really n factorial times n plus 1. Well, because we know n plus 1 is 1 more than n, these cancel out. And then we're just left with 1 over n plus 1. And there's our answer. So we kind of just, that idea of knowing what a factorial is and what the numbers are up to that, even when we don't know that value. All right, let's use our sigma notation now. We're going to define the sum of the first n terms of a sequence is represented by summation or sigma notation. Sigma notation is when you have this Greek letter sigma. It looks like a kind of a big E, but it's a Greek letter sigma. And this is our function. This is our start number, and this is our end number, okay? But this is our function that we're plugging into. So for this case, if I is 1, that's our starting, so we're going to say a sub 1 plus a sub 2 plus a sub 3 plus a sub 4, all the way to whatever the nth term of a is, okay? I is also called the index of summation. N is the upper limit, meaning that's where you end, and 1 is the lower limit. Okay, so if I wanted to find the following sum, remember this is summation notation. Here's our function that we're plugging into. Here's our our lower limit, and here's our upper. So we're going to find the sum of our starting point is 2 plus 3 when I is 2. And then we're going to go all the way up until we get to 7. So then you're going to go add, we'll make this black, add 2 plus 3 times 3 is the next one, plus 2 plus 3 times 4 is the next one. We're going to do this all the way up to 7. And then we have 2 plus 3 times 5. And then we're going to add 2 plus 3 times 6 plus 2 plus 3 times 7. So we're going to add these all up. So this is going to give us 2 plus 6 is 8. 2 plus 9 is 11. 2 plus 12 is 14. 2 plus 15 is 17, 2 plus 18 is 20, and 2 plus 21 is 23. Add that all up, and we get 93. So the summation of this equals 93. Almost done. And then the sum of the terms, so the sum of the terms of a finite or infinite sequence is called a series. So a sum of the sequence is the series. So if we consider an infinite sequence, it goes forever, the first term, second term, third term, and so on. The sum of the first n terms is called a finite series because it ends, and it's a sum. Or we can also call that the partial sum of the sequence is denoted by first term plus second term plus third term plus whatever the last term is. We can use our summation notation. The sum of all the terms of the infinite series is called an infinite series and is denoted by the first term, second term, third term, sum until that infinite number. This is our function that we plug it into, but our lower limit is 1 and our upper limit is infinity. We do have a way to solve this as long as it is a decreasing sum, but we'll show that to you later. See you later.